You know that feeling stuck in an emergency room surrounded by what feels like total chaos? It's so unpredictable. But what if it didn't have to be? What if AI could actually predict how busy an ER is going to be, maybe even a few days out? Well, that's exactly what we're going to dig into. So, yeah, why are ERs just so unpredictable? It's the central question, really, for hospitals, for doctors, and especially for us, the patients. I mean, this constant not knowing is what leads to overcrowding, those super long waits, and it puts a massive strain on the whole healthcare system. The real puzzle here is, how do you plan for something that feels completely random? Okay, just look at this. These graphs show daily patient visits for 6 different hospitals over 15 years, and it is not a smooth, predictable wave, is it? It's this chaotic, jagged line, a real rhythm of human crises. You can practically see the big spikes from a bad flu season, and then the dips when it's a holiday. This is the beast that hospitals are trying to tame every single day. So, to try and get a handle on this, researchers basically went on a quest, not for an actual crystal ball, obviously, but for the next best thing, some kind of forecasting model that could look at all that chaos and actually find a pattern, something that could predict what's coming next. Probably the easiest way to wrap your head around this is to think about it like a weather forecast, right? Meteorologists sift through tons of data to tell you if you're going to need a jacket tomorrow. Well, the goal here is pretty much the same. But instead of predicting rain, they're trying to predict the number of people who are going to walk through those ER doors. All right, so to find the absolute best forecasting tool, the researchers set up a kind of high-stakes competition, a technological showdown, if you will. They pitted 3 totally different types of predictive models against each other. So let's meet our 3 contenders. First up, you've got the veterans. These are your classic statistical models, things like Ceramex and Profit. They're the old guard, really good at spotting historical patterns and cycles. Then you've got the specialists. These are machine learning models, like LightGBM and LSTM, custom-built to wrangle really complex, messy data. And finally, you have the newcomer. This is a pre-trained large language model, an LLM, called Kronos. Think of it as a general-purpose AI, kind of like the tech behind ChatGPT, but it's been adapted for this very specific task. Okay, so with our contenders all lined up, the stage was set for the ultimate test. The models were given a mountain of historical data and then handed one single, incredibly important challenge: predict the future. And we're not talking about a small test run here. This was a huge undertaking. The models were trained on 11 years of daily patient data from all 6 of those hospitals. Then, their job was to forecast patient numbers for the next 5 years, from 2018 all the way through 2022. And of course, their predictions would be checked against what actually happened. So how do you even keep score in a contest like this? Well, they used a metric called mean absolute percentage error, or MAPI for short. All you really need to know is this. It's basically the average error rate. It tells you how wrong a forecast was. And just like in golf, a lower score is better. Simple as that. But, and this is the absolute genius part of this whole experiment, there was a massive plot twist. That testing period, 2018 to 2022, it just so happened to include the biggest, most unpredictable healthcare event in 100 years, the COVID-19 pandemic. This wasn't just a test anymore. It was a trial by fire. Any model that was just looking at the past was about to have a very, very bad day. So, after all that, who came out on top? Which model survived this gauntlet? Well, the winner was a real surprise. So, let's start with one of the veterans, a popular model called Profit. And what you're seeing here is fascinating. Before 2020, it was doing a pretty great job. See how the light green line, its prediction, is hugging the black line, which is reality. But then, the pandemic hits, and the model just completely breaks down. Its predictions go way, way up, while actual visits cratered. It just couldn't handle it. Okay, but now, look at the newcomer, Kronos. This is the big difference. Even with all the wild, unprecedented swings of the pandemic, its predictions stayed remarkably on track. It didn't just break, it actually adapted to the new chaos as it was happening. It's pretty incredible to see. And when you look at the hard numbers, the difference is just wow. Profit's error rate exploded from a respectable 6% before COVID to a massive 38% during it. It was basically useless. But Kronos, its error rate barely budged. It went from about 6.5% to just 9%. That's not just a little better, it's in a completely different league. So what's the bottom line? When all the dust settled and they tallied up the scores for the entire 5-year period, Kronos, that's the pre-trained LLM, came out on top. It had the lowest overall error rate, just 7.59%. The newcomer didn't just compete, it beat the veterans and the specialists, hands down. Okay, so an AI model won a data science competition. Big deal, right? Why does this actually matter to you and me? Well, because this is about so much more than just numbers on a graph. This is about taking those super accurate predictions and turning them into something real. Better, safer, and faster healthcare for all of us.
So let's break down what this could actually mean in the real world. It means hospitals can see a big surge coming and make sure they have enough doctors and nurses scheduled. It means they can manage their resources better, things like beds and critical equipment. And for you, this all points to one thing: shorter wait times and better, safer care when you really, really need it.
And that brings us to the big final question, doesn't it? What this shows is that a general-purpose AI can learn to predict one of the most chaotic systems out there. So, if it can tame the chaos of an emergency room, what else can it do? What about global supply chains, or traffic flow in a huge city, or maybe even our power grid? Suddenly, that crystal ball doesn't seem so far-fetched after all.